In this course, you will learn about the different types of machine learning models and how the history of machine learning has led to this point where deep learning models are so popular. The training of a deep learning model usually starts with random weights. How do you initialize these weights and how do you change those weights so that the model learns? You learn how to optimize models using loss functions, and you learn how to evaluate those models using performance metrics. As you learn how model training and evaluation work, you will also learn about the common problems that can happen when you do machine learning, and you will learn how to mitigate, that is, how to reduce the incidence of those kinds of problems. One of the most common problems that can happen is a lack of what is called generalization. When you create a machine learning model and it works well in your experiments, but then fails to perform well in production, the failure point will often involve how you created the machine learning dataset. So you will learn why you often need 3 identically distributed datasets and how to create them in a repeatable way. Creating a machine learning dataset is a practical skill. It's something that you do not want to shortchange. Give yourself time to absorb the lessons. So we will start out talking about the historical evolution of machine learning, from its use in applications like astronomy to now where it's used widely in commercial applications to automate many tasks, to augment the way those applications work. For example, machine learning is used to read house numbers from Street View images, to add labels in Google Maps. But while talking about the historical evolution, we'll also describe how deep learning techniques incorporate many of those improvements brought on by earlier machine learning methods like decision trees and random forests. In the optimization module, we will set up a supervised learning problem and find a solution using gradient descent. Then we will learn about performance metrics and how to choose between different models. Finally, we'll wrap up the module by developing an intuitive understanding of neural networks. You will explore the impact of things like batch size and learning rate using a cool tool called the TensorFlow Playground. Good machine learning requires that we create datasets and models that permit generalization. So we will talk about methods of doing so in a repeatable way which support experimentation. The entire purpose of machine learning is to be able to make predictions based on new data. So it's very important that we do not overfit our model on our historical training data. So if we have a generalized model that's trained on images of meals, for example, then it should not expect that all meals are plated and served on ceramic plates like that dish of spaghetti. It should also be able to recognize the home-style South Indian dishes on the bottom as also a meal. So that's what we mean by generalization. Just looking at that photograph has made me hungry. I'll leave you in the great hands of my colleagues. See you around.